A student investigates how different surfaces radiate energy as they cool. Figure 9 shows some of the apparatus used in a part of the investigation. Describe how the student could collect data to show how the rate of cooling of the container and water change with time. So what we're saying here is over time, energy will be transferred out, radiated as infrared radiation, and as a result, the temperature inside here will cool down. So it's quite simple. All you have to do is put a thermometer in here and just check the temperature at regular intervals. So use a thermometer, check temperature at regular intervals, and that is how you can monitor, or you can show how the rate of cooling in the container and water change with time. Figure 10 is a graph of intensity against wavelength for the electromagnetic radiation emitted by a halogen lamp. So you can see only this part is the part we can see, so that when this is visible light, all of this would be invisible to us. So most of what's emitted by a halogen lamp is actually invisible to us. Describe how the intensity of the radiation varies with wavelength in figure 10. So this is a bit tricky because there's not a nice obvious pattern. It goes up and down, up and down. So actually what you can say is there's multiple peaks, and most of the radiation emitted is outside of the visible range. So intensity reaches a peak value. You can see there's a peak over here, and most radiation is outside the visible spectrum. Remember, they've given you this for a reason, so do use what's in the graph to your advantage. Okay. Figure 11 is a graph of temperature against time for a halogen lamp for the first 120 milliseconds after it's been switched on. So you can see the temperature is going up very quickly, then leveling off over here. Calculate the gradient of the graph at a time of 30 milliseconds. State the unit. Alright, so this is for 4 marks. There's a lot to do here, and it's only a triple only question rather. So you can get various answers here. So let me just break this down. So the first thing you need to do, I would say, is you need to pick a suitable point on the graph. So obviously it says 30 milliseconds here, so that would be here, halfway between 20 and 40. So you go up the graph and draw a cross very neatly on here. Now this is where there'll be variation between student answers. You then draw a tangent line. Now the idea of a tangent line, imagine just like you're doing refraction, imagine there's what we call a normal. Imagine there's a 90-degree line like this. Okay, we are basically drawing a line at 90 degrees to this line here, 90 degrees to that, and that's what a tangent is. So here's my tangent here. It's not easy to do perfectly, and everyone will have a slightly different answer, but roughly it should be broadly within a range which is suitable or acceptable. So you put the tangent there, and then you need to work out the gradient. Now the gradient is y divided by x. So you take the values on this side and divide them by the values on this side, but only a certain amount of value. So you have to look for where a perfect right angled triangle forms across your line. So I've put mine here and here. You can use a smaller space, you could do your right angled triangle here or a tiny one here, but I've done this one here because this is where I found the line, my tangent line bisects a whole number or whole square, and that's what you're looking for, where it bisects the corner of a whole square nice and neatly. Not here, like if you look, let's zoom in a bit more, not you can see over here it's going through half a square, whereas here it's going through the corner, here it's going through the corner. So we're looking for a corner. Right, now we can count. We basically have to use the scale to work out the value on this side. You don't just count the number of squares, you have to use the scale. So if you do that, you'll see it's 140 on this side, 140 units here, and 68 along here. Now to work out gradient, you do y divided by x. So far, just by doing this, you'd have got quite a few marks. So y divided by x is 140 divided by 68. So 140 degrees Celsius divided by 68 milliseconds. And you need to state the unit. Now this isn't a unit we use commonly in science at all, but you have to work it out. So we're dividing degrees centigrade here by milliseconds. So the unit would be degrees centigrade per millisecond. Explain why the temperature of the lamp rises and then remains at a constant value. So if you look here, you can see it's rising and then leveling off. So when something is increasing in temperature, basically what's happening is the rate at which energy is being supplied to an object is greater than the rate at which energy is being emitted from an object. So because it's absorbing more heat than it's emitting per second, it's heating up. A cool object will emit more heat per second than it will absorb. So the rate at which it emits heat is greater than the rate at which it absorbs heat. And an object which is at a constant temperature will basically emit and absorb heat at the same rate. So it stays at the same temperature. So that's how we basically say it. Now we have to write it. So temperature rises because the rate at which energy is supplied to the lamp is greater than the rate at which energy is radiated or emitted. The temperature becomes constant when the rate at which the energy supplied to the lamp equals the rate at which the energy is radiated. So it's quite a lot to write there in a short space, and you could probably say it with less, but at least you can understand it clearly.